So we're gonna do what section for this one is a 5.5 substitution. But we should know all the antiderivative of this one, right? So this is from 4.10 antiderivative. This is the formula. With derivative, the first one is power law. Then we integrate antiderivative. Then we add 1 for the power, then divide by new power. And then always we do plus C because there's a constant term, right? And then ln x with derivative, then we get 1 over x. What if we antiderivative 1 over x, then we get ln x plus c, right? And then e, exponential function is really nice. With derivative e to the x, then we get e to the x, right? Then we integrate antiderivative, then we get that. And sin x with derivative cosine x, we get the sin x back, right? Then with derivative cosine x, then we get the negative sin x. Then with antiderivative sin x, then look, they don't have a negative sign here, right? Oops. I break my stuff every time. So we don't have a negative sign in the integration here, right? Can you see that? Which part we are doing? So this one, right? We have with derivative cosine x, but then we get the negative sin x, but we want to do antiderivative of sin x, but there is no negative sin x, right? That's why we have a negative. The answer is negative cosine x. Can you see that? Okay. And then with derivative of tangent x, then we get the secant square x. Then what's the antiderivative of secant square x? Then tangent x. Antiderivative, we're going back, undo every time, right? So here, derivative of cosecant x, we get negative cosecant x, cotangent x. The antiderivative of cosecant x, cotangent x, this is the same as the negative earlier, right? So we have a negative sign, but in the integration, they don't have a negative sign, so we have to put the negative sign in the answer, right? Then what's the derivative of secant x? Then we get the secant x tan x. What's the antiderivative of secant x tan x? Then we get the secant x plus c, right? Now, we have another trick, cotangent, derivative of cotangent x, then negative cosecant square x, but then we antiderivative of cosecant square x dx because they don't have a negative sign here, right? So we put the negative sign here, okay, instead of there. All right, then we're gonna do inverse later, so let me talk this one later, okay? So we have actually, yeah. Let me talk and then I'm gonna talk more since we are here. So we have inverse of a sine with derivative of that, then we get 1 over square root of 1 minus x squared. Okay, this is the form. If we have only x itself, right? If there is u, then we have to make a u prime channel, right? Okay. Now, antiderivative of 1 over square root of 1 minus x squared, that is inverse of sine x. We derivative inverse of tangent x, then we get 1 over 1 plus x squared. This is a default, okay? If there is more than x, we have to using chain rule, right? Then there is more advanced. We're not gonna have this kind of a simple one. We're gonna have always the advanced one, okay? So we do that later on. Then antiderivative of 1 over 1 plus x squared is the inverse of tangent x. Then secant, inverse of secant of x with the absolute value. Then this with derivative of this one is 1 over x. Sometimes they have some book indicate the absolute value too. So absolute value square root of x squared minus 1. Then what's the antiderivative of 1 over x? Square root of x squared minus 1 dx. Then that is inverse of secant absolute value x plus. So this one, you must remember everything, okay? The table, which I showed you, this one. It's about all the basic and then trick and inverse of a trick, okay? Please remember everything so that you can recognize the problem, all right? No. Okay, so let's do that. Uh, 5.5, I want to start definite integration. So definite integral for substitution, okay? 5.5. So let me write down part 2, huh? Let me just using part 2 for definite integration, definite integral. So definite integral means there is a lower bound, lower limit, and upper limit, okay? So if we have let me start with the theorem 5.8 substitution with definite integrals. Let u equal to g over x and let cannot read g prime. Is it g prime or is it continuous over AB close interval and let f be continuous over the range equal to 0 x. Then we have integral from a to b. Then f of g of x, g prime of x, dx. Then welcome. G over a, we change that, and f of u du. Okay, so basically we change the their limit as well. So let us do this one first. Let me do slow, okay? We understand. Evaluate. Okay, we will use substitution. Why? Because there is a channel there in the integration. Okay. All right. So only if you practice a lot, then you can just set up the U quickly. Okay. when you practice. So at the first time, you don't know which one you have to set it up, okay? But then let us looking at this one. Which one you want to set it up? Let's just try out. Let u equal to. We have to try out with a variable. So since this is a two term, it can be this one or it can be this one, right? We cannot pick or just the 2x cubed, right? Because there's two terms. So what do you want to pick? X squared or 1 plus 2x to the third power? What do you want to pick as u? Just tell me. You want me to pick it up?
1 plus 2x to the third.
1 plus 2x to the third. Okay, very good pick. All right. Then, like with derivative, the left side. Then with derivative right side, right? This means, what do you get? Left side.
Just du.
Du over dx, right? Like in
yeah.
differentiation, like y with derivative y, then we get dy over dx, right? How about right side, what do you get?
6x squared.
So 6x squared, right? Now we times the dx both sides. Then what do you get? Du will be 6x squared dx, right? Okay, now we're gonna change everything. The u from the x variable. Can you see that? The original question has all the x. Now we're gonna change all the u, all right? Okay, so is there 6x squared dx in the original problem? I'm asking you. Is there 6x squared dx? No. Then we divide by 6 both sides because we see the x squared dx there. Can you see that? Oops. So we see that only x squared dx, not the 6x squared dx, right? So we divide by 6 both sides. Sorry, no space. So we get, this one will be 1 over 6 du equal to x squared dx. Okay? Now, we are telling this, 1 over 6 du is the same as x squared dx. Make sense? So 1 over 6 du will be replaced there. Is it clear? Okay, so let us do this one. So let us change the variable later. So we set it up 1 over 6 du as x squared dx. Now we set it up u as 1 plus 2x cubed, right? So it will be u to the 5th power. Can you see that? But then we did a property last time. If we have a constant in front of the variable, we can take it out from the integration symbol, okay? Now, we can use power rule. The power is 5th, so we can add them and divide by new power, right? then we have to evaluate from 0 to 1. Okay, definite integration is like that. We substitute the number there, lower bound, upper bound. So basically, we have the uppercase of f of b minus uppercase of f of a. We are using this one, okay? Where the uppercase of f is antiderivative of small case of f, right? All right, so since no space, let me erase top. Okay, now, before we substitute the number there, we're gonna substitute back into x variable because we did not change the variable yet. So let me show you later how to change the variable. All right, so we do here. All right, so 1/6, and then we have a 6, which is 36, right? Now, u was 1 plus 2x to the 3rd power to the 6th power, right? Is okay? Then we're gonna evaluate it from 0 to 1. Nice number, 0, nice number with 1. Then 1/36, 1 plus 2 times 1 to the 3rd power, then 6th power, minus, can you please calculate? So what do you get this one? That's 2, 1. 3 to the 6th power. Three to the 6th power. Oh, 18th. No, we do it like this. 1 to the 3, which is 1, right? Then there's 2. 3 to the 6th power is 729. And it's 1. Now we have a 728/36. Since even number, can you simplify this one? What do you get? Simplify this one. Simplify as a fraction. How about divide by 4, numerator, denominator? Okay, thank you. 182 divided by 9. Thank you so much. Okay, so this is the answer. All right, now I'm gonna show you, we're gonna change the limit, okay? So this limit is not like a limit x approach to 0 like that, not like that, okay? So we call this as a lower limit, your book. Other book is a lower bound, and then this is the upper bound, upper limit, right? So if there is a number, lower limit, upper limit, then we said definite integrals, okay? If there is no number, then we said indefinite integrals, okay? Now, we're gonna use everything, but then just change the, let me erase it there. I did not finish the sentence. Just to change the variable, the lower limit, upper limit. Okay, so we have from this one, we have u equal to 1 plus 2x to the third power, right? But then look at the limit when x equal to 0, when x equal to 1, that means, right? Okay, so when x equal to 0, we just substitute there. So we have u equal to 1 plus 2 times 0. So we get 1, right? When x equal to 1, then u equal to 1 plus 2 times 1 to the third power, which is 3. Okay, now we will change that. So we're gonna do from 1 to 3 instead of 0 to 1. So we will use the same thing, u to the 5th, right? Then we know that that's 6, u to the 6th power, correct? And from 1 to 3, right? Then we get 1 over 36. What's the u? We don't substitute back to u, right? So we have u to 3 to the 6th power minus 3 to the 1st power. I think we get the same answer, right? Okay. This is another way we can evaluate definite integrals. So change the lower limit, upper limit. Okay. All right. So let us do other one. Let me use this one. Okay, what do you want to set it up you?
Um, 4x squared plus 3.
Excellent. So 4x squared plus 3. Now we have experience, so let us just using the du with derivative left side, okay? Then what's the derivative of right side? Eight x, very good. Okay, dx. Okay, so do we have 8x dx there? No. So since we don't have 8 there, we have x dx there, right? So we're gonna divide by 8, both sides. So we will have 1 over 8 du equal to x dx. Okay, so we will replace 1/8 du in the x dx, okay? So x dx. Let us take out the 1/8 there and du there, okay? Now, we set it up e to the u, right? Okay, we antiderivative integral e to the u. What do you get?
I think it's still just the same. It's e to the u.
So we do e to the u from 0 to 1. Okay, so 0 always easy, 1 is always easy. I mean, there's nothing to we need to change the variable. But I'm gonna show you change the limit. I meant to limit, not the variable. Okay, so then 1/8 e to the u was 4x squared plus 3 from 0 to 1. Now we have e to the 4 times 1 squared plus 3 minus e to the 4 times 0 plus 3. Now, can you please calculate, give it to me approximation? E to the 7 minus e to the 3, right? Okay. What do you get? $134.56. Very good. And then we have u equal to 4x squared. I'm gonna show you change the limits. Okay. But 0, 1, as I said, 0, 1 is always easy. Just keep that, right? We change the limit if there is a not nice number, then we change that. All right, so when x equal to 0, u equal to 4, 0 plus 3, which is 3. When x equal to 1, u equal to 4, 1 square plus 3, which is 7. Okay, now we have from 3 to 7, and then we have 1/8 e to the u du, then 1/8 e to the u from 3 to 7, right? 1/8 e to the 7 minus e to the 3. Then it's the same as 134.57. Okay? I think this is the same work amount. What do you think? Yeah. The right side, the blue one is we change the limit, then the processing of integration is easier, but we do work, change the limit, right? It's up to you. So either one, we get the same answer. All right.